Hello everyone, welcome back to Diksha Karnataka YouTube channel. And today is a special day because I am going to discuss a very important topic, that is second PU pre-board paper analysis for all the district. So I have personally reviewed question papers from almost 31 out of 31. I have reviewed almost 30 district. One or two district I did not get, otherwise almost 30, 29 and plus 1 30 district papers I have reviewed personally. I have checked and I found there is a common pattern among the question. What are all the common questions? What are all the some few questions are uncommon as well, but they are repeated across the district. So we are going to discuss all such questions, and then also we are going to discuss about what is the overall paper difficulty level and what are all the conclusion from the paper. So everything I will going to discuss. So let's see. First we will discuss about the question paper difficulty. So overall, whatever I have seen, that about 60% of the question paper is easy, common questions, mostly common questions. It is asked almost every alternate year or every year in the matter of fact. So those questions consists of 60% of the questions. There are about 30% questions which are medium level questions, which are basically consisting of your numerical questions, few questions which are not super common, not often asked. So these are but not difficult to answer. So they are in the medium category, and 10% questions are hard questions. They are mainly the MCQ sections. If you consider all the 30 districts and all the 15 MCQs, there are over 450 MCQs, and you will find some MCQ questions which are basically difficult questions, and you need a lot of understanding of the subject, understanding of the concept to answer such questions. You have to prepare harder for those questions, and if you are following our Chakravyuh series, then definitely it will prepare you for those hard 10% MCQs as well, because in the Chakravyuh series we are not only solving easy questions, we are also answering some difficult questions. If you have seen our Chakravyuh series, right? So that is very essential for you, all of you, to consider the Chakravyuh series. Now let's see the 2 mark question. Now I am not going to discuss 450 MCQ questions. This is completely impossible for me to analyze and categorize all the 1 mark MCQ questions into say 20 questions or 30 questions. It will be at least 100 questions. So that will be very difficult for me to do that part, but I have seen the questions, I have read the question, and I have understood, okay, there are some questions, few questions which are slightly difficult in terms of MCQ, and I will try to incorporate them in my upcoming Chakravyuh series as well. So stay tuned for that Chakravyuh series. Whatever chapters are remaining in those chapters, the questions will be incorporated, and already whatever we are doing, some questions are already incorporated, and we will keep on improving our Chakravyuh series. So don't miss out on that, and it is live. You can come and you can say, okay, this question came in our pre-board exam, so I'll be knowing that maybe you actually are ready for that or not. Right, now let's see the top 2 marker questions. Now some of these 2 marker questions, as I said before also, some 2 marker questions were asked as a 3 marker question, some 3 marker questions were asked in 2 marker questions. So 2 marker question, even if this is saying 2 marker questions, these questions are important for 3 marker questions as well. For example, the first question, mention any 2 basic properties of charges. They might say mention 3 properties of charges, 3 basic properties of charges. That will be a 3 marker question. So I have seen properties of charges coming in as a 2 marker question as well as a 3 marker question, but most commonly I have seen this is being asked as a 2 marker question. So that's why I have given this as 2 marker question. Also during my lecture series, Brahmastra series, I have mentioned that this can come as a 2 marker as well as a 3 marker. So you have to be prepared for that. So even if I saying that 2 charges of electric charges, 2 properties of electric charges, you have to prepare all 3 properties of electric charges so that you are ready for your final exam. Right, now state and explain Ampere's circuital law. So here this is also a common question being asked at least 5 to 6 districts. So this is a very common. Explain, state Ampere's circuital law, write its mathematical expression. State and explain Ampere's circuital law, state and write the mathematical expression and explain the terms. These are the common variation. So the language of the question varies, but the answer of the question remains the same. That is the main important thing, that that you have to understand. The language may not be the same as this, but the answer to the question, whatever the question they asked, the answer should be the same. That is integral of B dot dl is equal to mu naught I. Here B is the magnetic field, dl is the length element, mu naught is the permeability of free space, and I is the current enclosed by the closed curve. So these are the things that you have to mention. You have to possibly drawing a diagram, and I explain the law. So these are the very common questions. Next is state and explain Ohm's law. Ohm's law is asked also multiple times. One of the district they mention Ohm's rule. Actually not Ohm's rule. Ohm's rule is incorrect. It will be Ohm's law only. It is a law, it is not a rule. Okay, next is state 2 limitations of Ohm's law. This is also commonly asked. So if Ohm's law was asked 5 times, this was asked 6 times. So both of them are very important. All of the questions are very important from this section. Expression for Lorentz force. So Lorentz force expression was asked multiple times in a different format. Okay, so I have taken just the generic part of the question, that is Lorentz force between when the electric charge is moving in a electric and magnetic field. What is the force acting on it? Explain the terms. So they have either asked it like that, or they have asked directly Lorentz force and explain the terms. So that is also possible, that they might change the language and they say, okay, an electric charge is moving in an electric and magnetic field. What is the net force acting on it? So that is basically Lorentz force, right? Now the similar question was asked. This is also based on Lorentz force. When the force acting on a charged particle moving in a magnetic field, now it is only magnetic field, will be maximum and minimum. So they are asking about the angles, at what angle the force will be maximum, at what angle the force will be minimum. We have already discussed in our master series, right? These are all questions, are common questions. Okay, what is the displacement current? Write the expression for it. This is also a very common question. Sometimes they have asked from the electromagnetic wave chapter, they have asked uses of infrared rays, uses of UV rays, okay, uses of X rays, but they are the uses of different rays are varied across the district, so I have not included that. But this question is the most common question from this chapter. Okay, displacement current and the expression, explain the terms. Okay, so this is the most common question from this chapter. 2 conditions for total internal reflection, another common question. In 1 or 2 districts they have said what is total internal reflection, state 2 condition for total internal reflection as a 3-mark question. So total internal reflection can also come as a 3-mark question. I have seen few district or 2-3 districts, they have also given it as a 3-mark question, right? Now one numerical from this section, and the numerical questions varied a lot. Sometimes it is coming from electromagnetic induction, sometimes it is coming from the chapter electromagnetic potential, sometimes electric field, and the question from a numerical question varied a lot across the district. And as you know, there are 3 different blueprints, so different chapters are included in the numerical part. So numerical question varied across the district. There is no clear winner in this case. Okay, now let's move on to the next part, that is 3-marker questions. Let's see few 3-marker questions as well. Mention any 3 properties of electric field lines. Most asked question. Okay, most asked question from this section is mention 3 properties of electric field lines. So this is obviously the most asked question as well in the PU board, and in the pre-board also as well. We are seeing that this is the most commonly asked question. Distinguish between dia, para, ferromagnetic materials. So this is also common question. Some districts are asking differentiate between dia and para. Some are saying para and ferro, some is saying dia and ferro. Most common though dia and para. Most common out of all the differences is dia and paramagnetic. Diamagnetic and paramagnetic is the most commonly asked, but ferromagnetic also there in a few of the districts. So I have included everything in one question. Right, convert galvanometer to voltmeter or ammeter. This is also commonly asked question. 4 district I think asked voltmeter, 4 district asked ammeter. So this is very also another common question. Experimental results for photoelectric effect. So experimental results, experimental observation. Okay, Hallwach-Leonard observation. These are all same questions, and again same question, different languages appeared across the district. This is also another commonly asked question. Mention any 3 properties of magnetic field lines, even though it is not as popular as this one, but this is also appearing few district as well. Next is postulates of Bohr theory, another very commonly asked question across district. I think at least 10 to 12 districts ask this question, so almost 1/3 of the districts asking this question. So this is also very important question. Derive expression for motional EMF, this is also came at least 4-5 districts as well. Bio-Savart's law, another very common well asked question. Difference between interference and diffraction, I have seen, so this is not super common question, but this is a question which I feel is something new, which is not covered during my Brahmastra series. So this is a question which is asked at least 2 or 3 districts, and some uncommon question, so that's why I have included this in my class as well. And in one district they ask this question as a 5-marker question, right? So this is also asked in various way. So they have asked what is the wave theory, define Huygens wave theory or explain Huygens wave theory, and then difference between interference and diffraction. So that is why I have included this question in 3-marker question as well. Okay, so this is all, something unique question. So you have to prepare, if you want to prepare for this question, you have to follow your NCERT book. I have discussed briefly in my Decode NCERT series. If you later on require this difference, I can explain that while doing my chapter review series for the chapter. That time I will give you an add-on, and you can find this difference in that chapter, right? Numerical questions from this 3-marker question is very predictable. So either they have asked you binding energy problem. There are mainly 2 or 3 different binding energy problems. Okay, I have discussed I think 2 in my class. So 2 of them are very common, and few of them also asked convert 1 atomic unit into mega electron volt. That is also asked. So 1 U is equal to 931.5 mega electron volt. That is also asked across few districts. So this is very common. All the questions are coming from the nuclei chapter. So as you can see, the nuclei chapter, binding energy per nucleon, total binding energy, this is very commonly asked question from this chapter. So this is a, if you are preparing for numericals from this 3-marker section, and if you are strong in mathematics, definitely you should prepare the numerical from this chapter, as it is a very predictable question from this part, right? So either binding energy of helium, binding energy of oxygen, binding energy of nitrogen, binding energy per nucleon, where you have to divide it. So these are the 3 more common binding energy problems, and there is one more, atomic energy, convert 1 atomic mass unit into mega electron volt. So that is also another common question from this part. Now let's move on to the 5-marker question, the most important 5-marker question. Students rely on this, 15 marks are coming from this. So let's see what are all the common questions. Electric field due to a dipole, axis and equatorial plane. So this is also commonly asked question from this part. Mostly I have seen axial, but some also asked equatorial plane. So both in my opinion are important, so definitely you have to practice both of them. Magnetic field due to a point charge, not magnetic field, sorry, it is not magnetic field, this is electric potential. My mistake, I typed it wrong. Electric potential due to a point charge. So electric potential due to a point charge is also very commonly asked. So either of these 2 chapters are included, so electric field and electric potential. So from electric potential, if long answer type question is coming from electric potential, then this is the most commonly asked question from all the part. Okay, so and some cases they have asked, they have made the split question from this chapter, but I don't think that will be correct. So most commonly you will get what is electric potential if the question is coming from this chapter. Okay, electric potential due to a point charge. Another is conductivity of free electrons from drift velocity. This is a question which I have not discussed, but it is asked at least 5 to 6 districts. So I think this is also a thing that you have to incorporate into the derivation. You have to practice it. The derivation is very easy. There are few things starting from drift velocity. So starting from drift velocity means I is equal to NEA VD. Okay, VD is equal to EE. This is the magnitude of drift velocity, EE into tau, right? And another expression is J is equal to sigma E. These are the expression, and you have to find the relationship between this sigma and the tau, or find the expression for this sigma. Okay, we know that I by A is equal to a current density J, so J is basically sigma E. Okay, and what is I by A from this expression? I by A is equal to NEA. NEA is already divided, sorry, A is already divided here, so it is NEVD is equal to sigma E. Now put the expression for VD. These three expressions you can use it as a standard expression, right? So NE into VD is EE by M, so that is equals to sigma E. Now E cancels from both sides, so you get sigma, there is a tau also, sorry, there is a tau also. Sigma is equal to NE square by M into tau. This is the expression for conductivity of a conductor. So this is a common question which not super often asked in the board exam, but I have seen this asked across the different districts, so that's why this is a question which I feel is you have to practice it, and the derivation is simple. You can follow this formula. You have to explain the terms. Obviously you cannot just write the formula without explaining the terms. If you are doing so, the marks will be deducted. So first you have to write the expression, you have to explain what are all the terms, and then you can do the mathematics, which is easy. Cells in series and parallel. Cells in series is coming more often, okay, compared to the parallel, but parallel is also came at least a few districts, right? Next is magnetic field on the axis of a loop. This is the most common. Almost every district have asked this question. Almost every district except a few. Those who have not asked this question, they have asked force between two parallel wires carrying parallel wire current carrying conductor, unit length, force per unit length, or force between, force per unit length, both are common. Force between the parallel wires, or force per unit length between two current carrying long wire. Okay, so these are also two questions, but this is the most commonly asked question, so you have to practice it. Because the derivation is slightly tricky, you have to draw something, you have to do the mathematics, geometry, etc. is involved. That's why teachers prefer this over this. This one is slightly easier. And then also they have asked what is the definition of ampere. Definition of ampere is also a additional question. Whenever this question is asked, definition of ampere is always asked, right? Now what is a rectifier? Explain the working of a full wave, half wave rectifier using a circuit diagram. Draw the input and output waveforms. This is also very common question. Except few districts, they choose to ask about band theory, but there are very few, and I don't think band theory is going to come. Most of the district asked full, some of them also asked half wave rectifier. So in my opinion, both of them are important in your final view board exam. Now Wheatstone bridge is also asked, not as much as I have expected, but it is also asked in many of the districts. Okay, I was expecting that this will be asked almost out of 30, at least 15 district or 16 district will ask this, but it is not as common as this, but still it is common. 7 to 8 district ask this question. Some of them asked about parallel combination of cells, series combination of cells. Those are also asked in the part. There are some other questions which are, I felt, is not super relevant, except this one. Even though this is not commonly asked, I felt many districts are asking this question. That means it has some importance. Maybe that paper setter, whoever is setting the paper, they have a discussion amongst themselves, and they said, okay, this question is going to come in your board exam, so let's give them in the pre-board as well. So there is a pattern like that, right? Now numericals are mixed bag. Some numericals are easy, some numericals are difficult, especially if you are preparing numericals from the chapter current electricity. The questions was not super simple. A lot of circuit diagram based questions came. Okay, some cases they asked about based on Wheatstone bridge as well. Okay, but not balanced Wheatstone bridge. Okay, so they have given you different questions based on different cases. So circuit current electricity, that's why I don't recommend to answer questions from current electricity, numericals from current electricity. So what are my recommendation? Electric field, electric potential. So either one of them will come, and it has come in your board exam as well. And then we have AC and ray optics. AC and ray optics will definitely come in your board exam, but sometimes the questions from ray optics is slightly difficult, so I recommend to practice from these two chapters as well. Okay, if you have time, practice all 4 chapters. If you don't have time, you have to practice the last 2 chapters definitely to answer at least 2 numerical questions. Okay, so these are my observation from the all the 30 districts that I have analyzed. Okay, now what are my conclusion, what are my suggestion for your final board exam? Not much, I am not going to discuss too much. So first is prepare well for MCQs. MCQs are as the days are going by, okay, we are seeing that most difficult questions are coming in MCQs. They are asking some difficult numerical questions, which maybe itself is not a 1 mark question, but they are being asked as a MCQ questions as well. Sometimes they are asking some circuit based questions, sometimes they are asking some diagram based questions. So diagram based questions have increased in many of the districts. Okay, so MCQs are not super simple, you have to prepare well for the MCQs. What is next? 2, 3, 5 mark questions are mostly common, as we have seen that. Okay, there will be, if you are able to answer 5 questions from the given 8, then what is the worry about it, right? So the 5 questions that we are going to answer will be common. Okay, 5 questions you are going to answer will be common. Sometimes they may be the questions which you thought while preparing for the chapter is, okay, this is a hard question, if this question comes, I will not answer, but that question might come still. Okay, because that is a common question. There is no hard or easy question in the common category, right? You have to answer those common questions. If you have seen that question, if it is discussed in the class, you have to prepare that. Other than that, there will be some other new questions completely as well. Okay, that is not in your hand. There will be at least a few questions which never asked in the PU board. So those questions I cannot even predict, right? But whatever can be predictable, maybe say they are difficult to you have to prepare for those difficult questions as well, especially for numerical questions, especially for derivation questions, right? For example, the derivation of a circular coil on the axis, it is not super easy derivation, but you have to practice it. Even though this is not super easy, suppose in the exam they have given only 2 common derivation, other 3 derivations are out of your reach, or other 2 derivations are out of your reach, you have to write 3 derivations from there, right? So maybe they will give you derivations which you have never seen, so you cannot prepare for those derivations, right? But 3 derivations will definitely be common, so you can answer those questions. So 40 marks is easily scoreable if you prepare all the questions, most of the important questions I have discussed in this slide, right? Practicing numericals for 4 suggested chapters will definitely guarantee another 10 marks. So 50 marks you can score easily by going through this 2, 3, 5 marks and the numerical questions. And obviously I am not ignoring the MCQ and fill in the blanks. From there also you can score some marks. They are easy to score, but not super easy, obviously. But not all the MCQs are difficult, right? So there will be some difficult MCQs, there will be some easy MCQs as well. So you can score approximately out of 70, you can easily score 60 plus easily if you just prepare well, right? And my Brahmastra series has covered all the important questions, 2, 3, 5 marks and numerical questions. So if you have not watched them, don't forget to watch them. The Brahmastra series link I will try to give it in the description below. If not, then it will be there in the comment below. Okay, so you can check those videos, the playlist is there. Okay, all the subjects are done. So that will help you to revise all the chapters quickly. Okay, at least revise the important chapters. I have made a video on the all important chapters. You can check that out and you can revise those chapters from the Brahmastra series, and you will get easily, you can score 60 plus marks. Hope for the best, and I'll be back with more such videos. And one more thing that is coming up is the solution of the model question paper 1 very soon. So if you have not yet subscribed to our channel, and if you want the solution of model paper 1, please subscribe to our channel, share it with your friends, like this video. I'll be back soon. Till then, bye.